All right, let's look at number 11 on the written exercises. You have this equation and you're supposed to find its foci. You're supposed to graph it. So let me get a graph pulled up here. Okay. Now, this one we haven't found the x and y intercepts for, and I'm not going to here because I'd rather you see how you really normally work these things, okay? I chopped off my equation with my graph, didn't I? Okay, so let me rewrite it here. 4x squared plus 3y squared is 48. All right, one of the reasons I know this is an ellipse, just in case, you ever saw this and it wasn't in a section titled ellipses, is you've got an x squared term and you've got a y squared term and you have a plus in the middle. You might think, well, maybe this is a circle or something, and there's a way we would know it's an ellipse versus a circle. But I would know this was either an ellipse or a circle because of a positive x squared and positive y squared terms. Now, how am I going to graph this? I want to try to graph it first and then find its foci, because in the process of graphing it, I'll get the information I need for the foci. If you remember, this number over here on the right, where the 48 is actually supposed to be a 1 if this is an ellipse, and we're told it is. So how do I get it to be a 1? Well, I divide it by 48, and if I divide it by 48, in order to keep everything in the equation equal, I have to divide everybody by 48. Okay, so now 48 goes into 48 once, 48 goes into 48 once. Okay, I've got 1 over 1, which is 1 now. That's what I needed. Okay, but what about the left-hand side? What happened to it? Well, 4 goes into 4 once, and 4 goes into 48 12 times. So now I have x squared over 12. It's starting to clean up a little bit, isn't it? 3 goes into 3 once, and 3 goes into 48 16 times. So I have y squared over 16. All right, so this is an ellipse. I can get it in this form, and I know it's an ellipse now. If I can get 1 over there and have this look like this, I know this is an ellipse. Okay, now if you remember, in an ellipse, your major axis is your longer axis. So in this case, I'm going to have kind of a longer one than it is wider, kind of like that figure I sketched at the bottom. And if you remember, so this 16 is like my a squared, and so the 12 is going to be like my b squared. I know this has a center of 0, 0 because there's nothing subtracted up here from the x or the y squared terms. So I'm going to put my center down. And if a squared is 16 and it's under the y, then if you say a squared is equal to 16 and you square root both sides, you're going to get a is plus or minus 4. Okay, so what does that mean? That means I'm going to go to the center. I'm going to count up 4 and down 4. That's my major axis. My foci are going to be somewhere on that major axis, so I'll get them in a minute. But in order to get the foci, I had to know what either a or a squared was or b and b squared was, because we have that little equation that kind of helps us find the foci. We'll use that in a minute. Now my b squared term is 12. So if I said b squared is equal to 12 and I want to know what b is so I can count from the center on the x-axis, I'll have to square root both sides, and you get plus or minus the square root of 12. So the square root of 12 would actually be 12 is 4 times 3. 4 is a perfect square, so the square root of 4 would be 2 out front, and then square root of 3. Now the square root of 12 is somewhere between, let's see, 3 squared is 9 and 4 squared is 16. It's somewhere between 3 and 4, and I can't get any accuracy on this anyway, so I'm just going to go ahead and kind of graph somewhere between 3 and 4. But if we were able to graph more accurately, we probably want to go get that exact decimal value. All right, so let me join my ellipse up now. It's almost a circle, but it's just a tad bit longer than it is wider. Now for my foci. My foci equation, you remember we cleaned that one up in the book a little bit so it would be easier to use. It's c squared is a squared minus b squared. Okay, well my a squared was 16 and my b squared was 12, so you get c squared is equal to 4. So if you square root both sides, you get c equal plus or minus 2. Okay, so my foci are going to be at plus or minus 2 on the major axis, so that's how far I'm going to count from the center. So that's here is a 2, and here is a minus 2. I actually graphed my foci in yellow. Okay, so let's write the foci down because they actually ask us for those numbers. So the x on the y-axis is 0, and the foci would be plus or minus 2. There's actually 2 of them, but again, I'm just going to use this short mathematical notation to say 0, 2, and 0, minus 2. And so that's all they wanted us to do. It's kind of easy to graph these things. You're just basically taking, if you think about what we did, we took the square root of this number and counted from the center 0, 0 on the y-axis, that square root of that number in both directions. And then for the x-axis, we go to the center and we count the square root of 12 both directions. And then we could find our foci because now we know a squared and b squared. It goes pretty quickly once you know what to do. So on any of these that don't have a 1 over here, that's how you're going to handle them. You're going to divide by that number, and when you do, it will usually clears out all these numbers on top, and you end up with an equation that's easier to graph. So that's what you're going to do on these. Now, number 15, we can figure out what to do here if you think about number 1 on the oral exercises, and then we did number 1 on the written exercises. And what we saw was if our center is at 0, 0, and we're assuming it is in all of these problems in this section, the problem is a lot of times that's not the case, but that's okay. For this section, this is good thinking exercises here. If we had a center at 0, 0, then when we find our x-intercepts, that's how far from the center I'm going to count out on my x-axis to make my vertices. Let's say this is the center right here where I put a line through it. I'd count out however many over in each direction. And so, and then on the y, our y-intercepts, if we have a center of 0, 0, we're actually, also points on the parabola, on the ellipse, and we would just join those and we'd have our figure. So since this is 0, 0, this is going to be an easy problem to do. If we have an x-intercept of plus or minus 5 and a y-intercept of plus or minus 2, we know that the x, we're going to have an x squared and we're going to have a plus y squared equal 1. And we know that that since the 5 is the x-intercept, that we're going to put a 5 squared, because really this plus or minus 5, this is given us, in this case, is actually our a value because it's the bigger number. And in this problem, it wouldn't even matter if I got my a's and b's mixed up. But this is actually the a is 5 and b is actually 2. But really, I don't even have to know that. I just know on the y-axis, if I'm going to count out plus or minus 2, then 2 squared goes here. So my equation ends up being x squared over 25 plus y squared over 4 equal 1. So this is actually a pretty easy problem to do. If you're not sure if you got this right, you might actually just do another one on your own, like number 17. I didn't assign it, but if you're wanting to practice one just to make sure you got it, that would be a good one to try.